Welcome, curious minds, to another deep dive. Today, we're really plunging headfirst into something that, well, it touches pretty much everything these days, from the smart gadgets maybe humming away in your home right now to, the huge networks running big corporations. We're talking about the Internet of Things, IoT, and specifically how we secure it. We've got some great sources lined up, including key stuff from NIST, that's the National Institute of Standards and Technology, and we'll also touch on important auditing standards like SSAE 18.
Yeah, and our mission today really is to give you a clearer picture of this, well, explosion of IoT devices. We need to unpack the unique security challenges they bring because they are different. And importantly, look at the solutions and the standards being developed to, try and keep us all safe in this super connected world. Hopefully you'll walk away understanding why that smart thermostat of yours might actually matter to big company security and what's being done to protect things.
Okay, let's unpack that explosion a bit first. We've all seen it, right? Connected devices popping up everywhere. Smart thermometers, security cameras, printers, lights, homes, offices. It's just, wow. Hypergrowth feels like the right word. But here's the interesting part, maybe the slightly scary part. Many of these things are designed to be, well, cheap and single purpose.
Exactly. And that focus on cost and simplicity often means security takes a back seat, a very distant back seat sometimes. Unlike, say, your laptop, which gets regular security updates, or should a lot of these IoT gadgets have minimal, sometimes zero, built-in security. They might run on software that's full of known holes, never patched, and their basic design, low power, small memory, makes adding strong security later really, really difficult.
So, okay, I'm working from home. I've got my company laptop connected, but on the same network, maybe I have a smart speaker, a connected fridge. Is that actually a risk? Like a real one?
Oh, absolutely. It's a huge concern. Think about it. That less secure home network, filled with potentially vulnerable devices, connects right into the corporate network via VPN. Suddenly, that cheap smart plug you bought could, theoretically, become an entry point for an attacker aiming for your company's data.
You don't even always know what's on your network sometimes, especially in a bigger house or an office setting.
That's another challenge. Just inventorying these things is hard.
Yeah.
And they all connect somehow, right? That's their network interface capability, Wi-Fi, Bluetooth, whatever. But they also often interact with the physical world. That's the transducer capability we mentioned. Sensing temperature, locking the door.
Ah, right. So it's not just data theft. Someone could potentially mess with physical things.
Precisely. If someone hacks your smart lock, they're not just stealing data, they could be opening your door, or disrupting heating systems, or much worse in industrial settings. That physical interaction really adds a whole other layer of risk.
It definitely complicates things. Managing them, knowing who's using what, authentication, it gets messy fast. And without good controls, malware infections, unauthorized access stuff could happen, and you might not even notice for ages. It really highlights why protecting these connection points is so critical, whether it's your home setup or the office. And that's where resources like risk.securioutoffice.world become really valuable. They focus on providing practical info for securing exactly these kinds of smart home and IoT devices. Worth checking out if this is on your mind.
Yeah, definitely.
So given all these device-level headaches, what are the bigger players like NIST doing about it? How do we actually start securing these things effectively?
Well, NIST is definitely leading a lot of the charge here. They put out practical guidance, like their document on securing small business and home Internet of Things devices. It's all about mitigating network attacks.
And a key piece of that puzzle seems to be this MUD protocol, Manufacturer Usage Description. Can you break that down? What is an MUD file, practically speaking?
Think of it like a really strict job description for this device,
Mm-hmm.
or maybe a digital passport. The MUD file tells the network exactly what that specific IoT device is supposed to do, which servers it needs to talk to, what kind of traffic is normal for it, nothing more, nothing less.
Okay, so it sets the rules.
Exactly. And then your router, or another network component, acts like a bouncer. It reads the MUD file and enforces those rules. If your smart light bulb, which should only talk to its control server, suddenly tries to connect to some random server offshore.
The bouncer steps in.
Right. The network blocks it because it's not following its MUD description. It keeps devices in their lane, basically.
And NIST didn't just theorize this. They actually built reference architectures, right? These builds.
Yeah.
Tell me about build one.
Yeah, so Build 1 was about demonstrating the core MUD concept. They used a Cisco MUD manager, that's the software enforcing the rules. They combined it with Forescout, which is good at discovering and identifying devices on the network, and DigiCert for the device certificates, sort of their digital IDs. Put it all together, and you have a system that automatically finds a device, reads its MUD file, and applies the right network access rules. Pretty neat.
Okay, makes sense. Then what did Build 2 add? You mentioned threat signaling.
Right, Build 2 layered on real-time threat intelligence. They used a special router in their test, integrated with services like GCA Quad 9 DNS and Threat Spot P. Now imagine a threat intelligence feed flags a specific web domain as dangerous. Maybe it's hosting malware or it's part of a botnet. With threat signaling, the router gets that alert and can immediately block all devices on the network from talking to that dangerous domain.
Even if the MUD file might technically allow it for some reason.
Exactly. The threat signal takes priority. It's a dynamic defense layer. Super important for fighting things like DDoS attacks, where thousands of hacked IoT devices are used to flood a target. This helps stop your devices from participating.
Got it. And Build 3, that involved Cable Labs Micronets and Wi-Fi Easy Connect.
Yeah, Build 3 looked at secure onboarding, how you safely add a new device to your network using Wi-Fi Easy Connect, or DPP. And it explored creating micronets. Think of them as little isolated zones within your main network.
Like putting all your smart home stuff in one bubble and your work computer in another?
Precisely. So even if, say, your smart TV gets compromised somehow, the micronet isolation stops the attacker from easily jumping to your more sensitive devices, like your laptop. It adds internal boundaries.
So the overall goal with MUD and these approaches is basically let the device do its job, but stop it from doing anything else, especially malicious stuff.
That's the core idea, functionality, but within strict guardrails. And NIST is very clear. For this to work, especially in homes and small businesses, it has to be easy to use. Nobody's going to manually configure MUD files for 50 devices. It needs to be mostly automatic.
Makes sense. There's also a technical detail about matching IP addresses, right?
Yes, that's important for making sure the rules work correctly. If the MUD rule expects the device to talk to a specific server name, the IP address lookup needs to match what the rule expects. Otherwise, legitimate traffic might get blocked. It needs careful implementation.
These kinds of foundational steps, developing standards and testing architectures, seem crucial for building more secure digital environments overall.
Absolutely. It's all part of building, you could say, a more cyber-safe city, brick by digital brick. Securing these fundamental components is key.
Okay, so we've got the device level, the network solutions like MUD. Let's zoom out now to the organizational level. How do companies manage this broader risk, especially with third parties and remote work? This is where things like SSAE 18 come in, right? People often hear SSAE and SOC reports mentioned together. Can you clarify the difference?
Sure. It can be a bit confusing. Think of SSAE 18 statement on standards for attestation engagements, NOM 18, as the rulebook for auditors. It tells them how to conduct certain types of audits, specifically those looking at a service organization's controls. The SOC report system and organization controls, that's the output, the actual report the auditor writes after doing the audit according to SSAE 18 rules.
And there are different types of SOC reports.
Yes, SOCM focuses on controls relevant to a client's financial reporting. Think payroll processors or financial service providers. SOC2 is usually more relevant to tech and cloud services. It covers controls related to security, availability, processing integrity, confidentiality, and privacy, the trust services criteria.
Okay, that helps. Now, SSAE 18 itself brought some significant changes when it came in around May 2017. What was the big deal for risk management?
The really big shift was around risk assessment. SSAE 18 now explicitly requires the management of the service organization being audited to formally identify the risks that could stop them from meeting their objectives. And they had to document this process. Auditors then have to understand that process and evaluate if it's complete and accurate.
So no more just saying, yeah, we kind of think about risks. It has to be formal, written down.
Exactly. The days of informal risk assessment, at least for these audits, are gone. Management has to formally take responsibility and show their work.
And what about third parties? If a company uses, say, a cloud provider, how does SSAE 18 affect that relationship?
That's the other critical piece. SSAE 18 mandates that if you rely on subservice organizations like that cloud provider or a data center, you need to actively monitor their controls. You can't just get their SOC report once and file it away. You need a process to understand the risks they pose to your service and continuously monitor that their controls remain effective. So ongoing vendor risk management becomes baked into the standard, pretty much. It pushes for active monitoring and separate evaluations over time. It's about ensuring that the entire chain of service delivery maintains effective controls, not just your own little part.
Wow. So whether you're just trying to secure your smart plug at home or you're a multinational managing complex services and vendors, Robust risk assessment, understanding your vulnerabilities, and keeping tabs on your suppliers, it's absolutely essential. Non-negotiable, really.
Couldn't agree more.
And for organizations trying to get their arms around this, especially the physical security aspects alongside the cyber controls, understanding and implementing SASA 18 is vital. That's why services that help with www.saphysicalsecurity.com compliance and overall organizational audits are so important. They help ensure the whole operation is buttoned up.
Yeah, tying the physical and logical security together is crucial under these frameworks.
What really hits me listening to all this is how connected it all is. The smart home security issues we started with and these big corporate compliance standards, they're not separate worlds, are they?
Not at all. They're deeply intertwined. That exact scenario we talked about, the vulnerable IoT device on a remote worker's home network that directly impacts the enterprise risk profile that SSAE 18 tries to address.
So the principles are kind of the same, just scaled differently. MUD trying to control device communication, SSAE 18 ensuring organizations control their processes and vendors.
Exactly. It all boils down to the same fundamental goals.
Yeah.
Visibility and control. Knowing what's on your network, understanding what it should be doing, and having mechanisms, whether it's MUD rules, threat signaling, or robust internal controls and vendor monitoring, to enforce policies and mitigate threats.
Right, gaining that visibility, understanding the purpose of every connected thing, and being able to dynamically react to threats, like those DDoS attacks that can cause so much disruption.
Absolutely, you need layers.
Yeah.
Securing the individual device at the edge is layer one. Then you need network-level controls, then organizational policies and procedures, and ongoing monitoring and auditing across everything, including your third parties. It's a continuous process, really. Achieving a truly secure ecosystem requires that multi-layered, vigilant approach. There's no single silver bullet.
What a fascinating journey. We've gone from, the tiniest smart sensor all the way up to these major enterprise audits. It really shows how layered and interconnected digital security has become.
Yeah, and the key takeaway for you listening, I think, is that whether you're just trying to figure out your own smart home gadgets or you're responsible for security at a large organization, understanding these different layers, device capabilities, network protocols like MUD, organizational standards like SSAE 18, it's all crucial for building resilience today.
Definitely. And maybe here's something to think about as we wrap up. A little provocative thought for you. As these IoT devices get woven even deeper into our lives, think personal health trackers, smart cities, managing traffic and utilities, how is our idea of trust and identity on the network going to change? And maybe more importantly, what's our personal responsibility going to be in maintaining the security and integrity of this increasingly connected world we're all building? Something to chew on.
That's a great question to end on. Thank you for joining us on this deep dive. We really hope this discussion gave you some new perspectives and maybe some useful insights into our digital future.
Thanks, everyone. See you on the next deep dive.